I'm continuing with identifying functional groups in molecules, but this time we're looking at a three-dimensional ball and stick structure. So to identify this, I am going to redraw it as a skeletal structure. I'll start over on the left. You can see 6 carbons in a ring, and it's completely flat. It tells you something about it. Tells you that these carbons have double bonds. This is an aromatic ring. Okay, that ring is connected to a carbon in a ring with 1, 2, 3, 4, 5, 6, 7 atoms. So this is a more unusual number. The blue is nitrogen. So I go to a nitrogen, and then a carbon, another carbon, a nitrogen, and 2 carbon. And you can see that this is not at all flat. But here, this carbon has only bonds to 3 atoms. Since all the hydrogen are shown, that means we're missing something. That means there's a double bond somewhere. Probably not back this way because we couldn't do a double bond there. So there's going to be a double bond to either this C or this N. This N has 2 bonds and not a third. There's no hydrogen coming off of it. So it needs a third bond. So that's where our double bond is going to go. Carbon with 2 hydrogen to another carbon with only 3 bonds. One of them is to oxygen. That oxygen doesn't have 2. It's going to be a double bonded oxygen. It's shorter here. Double bonds are shorter, so that's consistent. Make those single. Nitrogen to a carbon with 3 hydrogen. I'm mixing my structures here. Started doing an expanded structure after starting with a skeletal structure. All right. This carbon looks like it only has 3 things connected to it. And this one also, if they each have a double bond, that would work. Same is true as we go around. Now the big green is a chlorine atom. We've got another aromatic ring here. Looks quite flat. So let me draw this in an actual skeletal structure. Here is a second aromatic ring. With a chloro group there. Got a nitrogen with a methyl group coming off of it. C bonded to an oxygen, another C, another N, and a double bond to this carbon. Okay, so now we can see our functional groups more clearly. We've got a benzene ring there, a benzene ring there. We've got a nitrogen connected to 2 carbons. We've got a nitrogen connected to 3 carbons, but one of those carbons has an oxygen, and then we've got our chlorine. So these are the things we need to look at and identify. Chlorine gives you a chloro group or a halo group. More generically, we've got one of those. We've got 2 benzene rings, so we've got arenes, 2 of them. We've got a nitrogen here with a double bond and a single bond. That's got its own functional group name, but for now it's similar to an amine. We're going to say we've got one amine, realizing that if you study in more depth, you'll find out I called it the wrong thing. Here, we've got a nitrogen connected to carbons. It's also connected to an aromatic ring, so that could give it one name, but we're going to take this side of it that we know. It's connected to a carbon double bonded to an oxygen. That makes it an amide. We've got one of those, and it takes care of both the nitrogen and the oxygen in that functional group. Now, because this nitrogen is connected to 1, 2, 3 carbons, this is a tertiary amide. If we were to do the same with the amine, it's got 2 connections to that carbon and 1 to this. We might call it a tertiary amine. But of course we remember it's not an amine.